Sal Cordova, thank you so much for coming back here, you wonderful human being. How are you doing this afternoon?
I'm fine. Actually, if I can, um, I was out in the fall weather, so this is my better outfit.
That is
So
a
I'm doing
nice
fine,
outfit.
and I think we were talking backstage about nutrition, and I said that one reason I'm wearing suspenders now is I'd lost so much weight by going on a mostly high-fat meat diet, and I lost so much fat just by eating fat. Isn't that interesting biochemistry there? So this is a totally random thing, but I'm pleased to report that my glucose meter, I have one here, it's indicating I'm probably no longer pre-diabetic.
Wow,
So I'm
congratulations.
I'm very grateful. My cholesterol is probably going higher, but I think it's manageable. And plus, the latest research is suggesting maybe it's overblown that we're focusing on
Hmm,
it. So,
hmm,
and
hmm.
if I had to trade between having high cholesterol and diabetes, I'll trade having high cholesterol, and I feel great. So, um, it's great hanging out with you. Uh, so those are just some random thoughts. I started, looking at all my um, vitals and stuff, and it's like I'm feeling pretty good, and the numbers are showing positive signs. So overall, I have a lot to be grateful for.
And I painted a barn today.
You're kidding.
It's a big experience. I'm building a teaching studio in my backyard, but from all external evidences, it seems to be a barn, and we're painting it red to fit in with that general theme. And I painted it today. We're almost done with it. It's been a heck of a long time. You think that painting an external building would just be the easiest thing in the world? What more can you need? You need some paintbrushes, and you need some rollers, and you need some roller extenders, and you need some tarps, and you need some trays, and then you need the right kind of paint, and then you need to have the right amount of paint, and then you need to wait for a day that is neither too sunny or too windy or too cold or too rainy or too, and then everything just gets blown out of proportion. It's like, how does anybody do anything ever? So it's actually kind of a big deal for us that we've actually made some progress on,
Yeah,
on,
thanks.
on this. But I feel, very wholesome as the result of all of this. Okay, so picking up from our conversation from last week, we ended with my asking you the question, are you, and thank you very much for the wonderful conversation that we had last week. I was talking with a bunch of friends about our conversation in this last week, and about how my understanding of what the young Earth creationist community is like, and sort of the situation of young Earth creationism, has been really upended by talking to you. And to be fair, like, this is some of the stuff that the really anti young Earth creationist folk on the subreddit that we hang out in have been telling me, but I was loath to believe it from them because it just seemed too convenient that they would know all these really negative things. And you have convinced me. So thank you very much for this. But we ended on this major cliffhanger, in my mind, of are you a young Earth creationist because of the evidence or in spite of the evidence? And again, I will say that this is not like a got you.
Yeah.
It is fine in my mind, and this is something that I've been getting in some arguments about on the subreddit debate r slash Reddit slash debate evolution for anybody who's watching this. Recommended, a fun place to hang out. I've been getting it. Yeah, well, I think it is. I end all of my correspondences there with people feeling really good about myself and able to be a happier person for the rest of the day. But that's just me, maybe. But a lot of people there are like, well, like, if the evidence all points in one direction, or if the evidence even mostly points in one direction, like, then, like, one is obligated, like science demands that somebody go in that direction. I'm like, no, I don't think so. You can choose to go against the preponderance of evidence, and lots of times in world history, the preponderance of evidence has been on one side, and that side has been wrong, it turns out. And I find sort of wonderful and heroic people who believe things in spite of what they think the best evidence is, as long as they recognize that. So this is not a gotcha. I'm so interested right now. Which of those describes you better?
I'd say because of the evidence,
Okay.
and there is, I wouldn't say necessarily the way the state it is now. It's the trend of discoveries. So there's a little bit of extrapolation, and when you, it's kind of like I'd say just like there's this movie, 12 Angry Men, where they're almost ready to convict, and then there was one doubter.
Whoa, 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 whoa! No spoilers! No spoilers! No spoilers! No spoilers! But I take your point. I take your point to it.
Yes.
Yeah, yeah.
Sorry, well, see, but for the audience, we need to kind of give them the spoiler, and if they want to see it, I'm sorry, it kind of emphasizes my point. But
Yeah.
let's just take another hypothetical where the evidence looks so against a defendant,
Yeah.
and slowly it starts to look promising, and enough doubt starts to emerge, and it's like, well, it is already beyond reasonable doubt that he's innocent. He's innocent.
Yeah.
Getting that doubt, but then you keep exploring, and it's like, definitely, he's innocent, and you get more and more convinced, and then you still have all this trail of stuff that you want to try to explain away, to kind of reassure you. And I'm kind of in that stage where
Yeah.
I would say I've watched this unfold over 45 years, and what I had learned in 8th grade, so many things just started to, one piece at a time, it started to move forward. I've had the privilege of being involved in that, even at the scientific, peer-reviewed, secular level, and working with distinguished scientists. And as I keep talking, one breakthrough keeps happening right after another. And so I would say the momentum for me personally, even if I couldn't give you an airtight case today, I'd say, look, it felt like we were starting with zero. And when it starts to build momentum, it's like a team that is coming from behind. You're like, they're going to win someday. They're going to win by the end of the game. And that's kind of how I feel. So if someone were to say, well, where's all your evidence? I say, look, it's a little more subtle than that. It's the change. It's the momentum that I'm seeing. And that really counts for something, at this stage when there's still a lot of uncertainties on both sides.
Yeah.
And one side will claim we've got this. And I'm just like, yeah, you've been saying, for certain aspects of the creation evolution controversy, I'm like, some of you guys have been saying this for ages, and you end up being wrong. And so this is where I'm at.
Yeah.
And and I did want to tell you this. So that's a risky position to take, because obviously, we have no control over what the ultimate evidence we discover is. It is what it is. And we have to, for me, we have to take a risk. But as Captain Kirk of the Starship Enterprise once said, risk is our business. And that's kind of where I'm at.
One of the interesting things about my experience of having deconverted from Christianity because of the evidence at the time is that after getting over that very painful, always very, very, very painful experience, one becomes something of an intellectual thrill seeker. And I want to discover that I am so deeply wrong about something that I have reasoned my way into. And one of my fears is that I will not have that sort of adventurous, risky, total mental upset as large as that again in my life. Because I know that the odds of my being very correct on most of the biggest questions in life, they're not that great. I'm probably wrong about something big.
From your perspective.
Yeah.
Oh,
I think I'm probably right about everything, but of course I would think that. From like the universal perspective, like almost everybody thinks that almost all of the time. So what are the odds that I'm the guy who's right about that? So that is part of why I'm so interested in this. I suspect that as we talk about this, and as I kind of think about the things that you're going to tell me, over the next like weeks and months and years of my life, right? But I don't need to make up my mind at any exact point on this. I suspect that right now, like I will think that, well, like, no, I think Sal is kind of like he was too optimistic about this, and he's kind of seen this through a certain kind of perspective, which probably we shouldn't see whatever through. Blah 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 blah. That's what I suspect right now, but maybe I'm wrong, and I would be delighted to be wrong. It might be painful and terrible, but I'd be delighted if it was horrible like that. I think that what you're doing right now, like you're keeping a live option open. This is, I think, how a lot of really good science has worked over the last few hundred years. So thank you for keeping an option alive and seeming to be kind of aware of like where the evidence is and all this. So here, without any further ado, could you like list off a bunch of the, like when you talk about the ways that the evidence is swaying, what are 3 or 4 or 5
Sure.
or whatever you want to give us of the bigger pieces of this?
I'm happy to. If you will indulge me maybe for a minute or so. I was in the credits of the documentary Holy Rollers, the story of card counting Christians who took the casinos for millions of dollars. I was a skilled card counter, so the idea of beating the odds is really kind of fun. So I can't, unlike some evangelical creationists, they love preaching and wagging their finger at the congregation about what they should believe. That doesn't really describe me. I think it's kind of fun when you think you can beat the odds, and you actually do.
Yeah.
I got kicked out of so many casinos. My photograph is circulated because I was beating them using my mind as a card counter plus some other advanced skills. So, in fact, there's a casino up in your neck of the woods, Little Six, that's run by the tribe, and they're associated with another. That was one of my favorite casinos. Oh my goodness! And I had to escape there. So, I just want to tell you, I kind of like the spirit that you bring to this discussion. It's not about, I'm so used to all these personal attacks and making it, it's kind of a mean-spirited fight, and I've certainly fed the fire there, so I'm not trying to say I'm innocent of that. But I think fundamentally, it's just kind of fun to see. It's just like watching a football game and not knowing whether your team's going to win or not.
Yeah.
But you just want to, you got to be there. Just maybe they're going to pull it off and win at the last second. So now, specifically to your point, the origin of life. In 8th grade, in the mid-70s, I was being shown Jacob Bronowski's series. It was very popular.
Yeah.
And he's saying, this is the Uri Miller experiment, and this is how
The Ascent of Man, is that right?
Huh?
The Ascent of Man.
That's really the... Oh my goodness, I can't believe you knew. Even
book,
I'd
yeah.
forgotten the title. And they showed the Uri Miller experiment. And the sentiment, when you read the literature at the time, the sentiment was, we're going to solve the origin of life problem. And at the time, I even wasn't a creationist. I liked evolutionary theory, the idea of, the universe heading toward progress. It was around the time that we were exploring space, and I said, that's a very beautiful way to look at the realm of reality. Everything's going to get better, and there'll be never-ending adventures, and this whole thing, about space exploration and Star Trek. My dream as a little boy was to grow up and join Captain Kirk and Mr. Spock on their adventures. And so I was raised in a Roman Catholic home, and in the Catholic Church, and then as far as my parents, they didn't care. I had the Collier's Encyclopedia that had a picture of the progress, the ascent of man, basically. You see this warm little pond, and it becomes, creatures like fish, and the fish become land animals. The land animals become ape-like creatures, and then you have man, and then a caveman, and modern man, and then an astronaut, and then you see a picture of them flying to the stars. I said, that's a really cool view.
Yeah.
That's very optimistic. So, it was somewhat of a shock when I got the evangelical take, when they were just wagging their hands and their fingers saying, this is such an evil idea. I'm just like, I never thought so. So I'm just giving you the backdrop where I came. And so the sentiment at that time was, we're going to solve the origin of life problem. It didn't take long after I became an evangelical in the early 80s, that I began hearing funny things like, oh, this is too difficult to solve, we're entertaining extraterrestrials. And then somewhere in the 2010s, I don't know the exact date, the number one evolutionary biologist on the planet is now invoking multiverses because he thinks the origin of life problem is too difficult. And plus, with some of my studies in statistical mechanics, and a little bit of physical chemistry, I'm just like, I think it is a miracle. So that was probably the big thing. Now, it doesn't solve young Earth creationism, but that was like, whoa, that's a big problem. And then,
Yeah.
so for a long time, I was an old Earth creationist. Was not a young Earth creationist. I said there's a problem with distant starlight, and plus we have the Big Bang and all. But I was open-minded, and I went to graduate school at Johns Hopkins. I studied under one of Richard Dawkins' drinking buddies, who's a physicist, and I had to keep a low profile. I didn't want them realizing I was, very sympathetic to young Earth creationism. But I said, I'm going to study this. I need to know. And so this was around 2011. I studied quantum mechanics and general relativity and all these really difficult classes. And then I studied cosmology. And I remember sitting in one lecture on cosmology, and they're talking about all the various problems that have to be fixed with the Big Bang. And they said one of them, one way we solve all these, like there are three problems, one of them being the smoothness of the heat. And there are some other things. They said, well, we have the inflation field. And in the inflation field, or the inflation epoch, right after the Big Bang, they said, suddenly the universe expanded faster than the speed of light. So you have galactic amounts of matter moving faster than the speed of light. And I just about fell out of my chair, and I said, you're moving galactic amounts of matter faster than the speed of light. And I thought young Earth creationism was outrageous, and then I heard that. And as an aside, because this inflation epoch or inflation field has fallen a little bit out of favor, some people suggested alternatives like variable speed of light. And I'm like, gee, even in the secular world, you're going to invoke variable speed of light. So how is young Earth creationism any more outrageous than anything else? And then certainly when they start talking about multiple universes that we can't see or test, that's also in vogue to help explain things like fine-tuning. I said, okay, in my mind, as far as I'm concerned, at a personal level, this is no more, what the secular world is proposing doesn't seem to me any more outrageous than young Earth creationism at this point. The general public just does not know kind of the lengths that the secular world has had to go to try to patch up their cosmology. And then when the James Webb telescope came out, I met a lot of diehard, what they call, they're kind of sympathetic to steady state, and I have it in one of my books on cosmology. See if I have it handy. Otherwise, I'd grab it for you right now. No, I think it's in my other book room. But it said there's a battle for supremacy, steady state or Big Bang. And the critics of steady state said, that's outrageous. You're violating conservation of energy to have continuous creation of matter. And then the steady state guys who criticized the Big Bang advocates, they said, how's what we're suggesting any more outrageous than you guys, where the entire universe was created in a single Big Bang? And it's not really mentioned that at the core of the Big Bang, they have to sometimes, many scientists are uncomfortable, I have it in my general relativity book, with the idea of a singularity. And a singularity is where the laws of physics break down. And I'm like, okay, so you're coming up with theories. You don't really want to advertise that maybe at the core you sort of need things where the formulation of our laws in the present have to break down. I'm like, Okay, here we go again. This is not, young Earth creationism is not that outrageous if you scrutinize what is actually said in the secular world for origins. So, so again, just reviewing the origin of life,
Yep.
then the thing with the Big Bang, and then I started to find other things. Since I worked for John Sanford, he sent me off to study at the NIH graduate school, and I actually got retrained to be a biologist after studying physics and being in engineering. So about a third of my life, my professional academic life, was studying biology. People know me more for talking about biology, but 2/3 of my life was engineering and physics. And in the process, he sent me off to study, to be co-mentored by Joe DeWeese, who, by the way, was appointed by the governor of Tennessee to set science standards. He's a professor of biochemistry, adjunct professor at Vanderbilt, and a associate professor at Freed-Hardeman, cancer researcher. We published together at Oxford University Press, no less, and I'm very grateful for that opportunity. And as I learned that, I said, there are a lot of problems with evolving all the major protein families. And as I looked at it and as I studied bioinformatics, I said, these things sort of just like popped out of nowhere. I said, there's no common ancestor for all major protein families. And I started talking to I said, let me run this by the evolutionary biologists. Let me see what they have to say. And to my surprise, even though there's probably not a single peer-reviewed article that will admit this, they will even publicly say, yeah, Sal's right. There's no common ancestor for all major protein families. And I'm like, well, so then how's macroevolution going to happen? These major protein families like collagen, like zinc finger, eukaryotic zinc fingers, and spliceosomal orphans or whatever, they just sort of like, you can't track that in the fossil record, and there's no gradual ancestor. And I'm like, okay, now that I know the complexity of proteins, they are so deeply integrated, like a password. It's like, well, you almost have to sort of like appear whole for stuff to work, just like a car. You don't build. There's certain critical parts of a car that you don't build up gradually. Certain critical parts have to be simultaneously there for it to work. And that's true of major protein families that are also deeply integrated. So I began to doubt. I had even more fuel to the fire that I think origin of life had to be a miracle, but then also the evolutionary story, because I studied the proteins. So, okay, so that's origin of life, the Big Bang, and then the origin of major protein families, but still that's creationist, not necessarily young Earth creationism.
Yeah.
The two big evidences for young Earth creationism for me, and I'm doing a video on this, and I actually parried a little bit with evolutionary biologist Dr. Daniel Stern Cardinal recently, and I kind of posted a video on his mistakes in understanding basic biochemistry. The fossils have, there are both radiometric clocks and then chemical clocks. Now, a chemical clock is not reliable for a specific age, except it's like a car. You could say, okay, what is the miles per gallon of a car? It's like, well, and then it has one tank of gas. And it's like, well, you can't reliably tell what the range of a car is because it depends on all the environmental conditions that's being driven and by the driving habits of the driver, et cetera, et cetera.
Yeah.
And they'll say, okay, it's not you can't reliably predict the range. And I'm like, well, you can reliably predict kind of like what is the outer limit, the extreme limit of its range. You may not be able to get the exact, when will the gas tank actually run out, but you can't say that, my Toyota Prius, and I love Priuses, that hybrid architecture, if I said it can go 10,000 miles, people are like, no, it's not going to do that. I could probably get 700 miles, in really, really, really good conditions, and I'd have to drive like a maniac, 35 miles an hour on a 70-mile an hour highway if I could get away with it. But there'll be limits. And likewise, for these chemical dates, it's like, look, we can't use it as an exact clock. We can use it as a marker of how old something cannot be. And I've done research in that, and that's when I began to get excited, because I said, okay, I can actually use my math skills, I could use my understanding of differential equations and their solutions, and then also, now that I'm, when I got trained in statistical mechanics and thermodynamics, a little bit of physical chemistry, I began to see, it's like, hey, we definitely haven't solved the problem of radiometric dating, but you can't run away from clocks like racemization, peptide bond erosion, deamination, depolymerization, and oxidation. And so, when we talk about the top tier chemists, they're like just kind of shaking their heads. People like James Tour, Marco Seberlin, Stephen Taylor, and chemists are, they may not come out on YouTube and say these are problems, but privately we talk about it. And even I talked to one radiometric dating expert. He's on my YouTube channel, Evidence Reasons Academy. And he was just hammering me on radiometric dating. He said, look, you can't run away from this. And at the very end, I said, what about all these chemical dates? And I listed again, oxidation, racemization, depolymerization, et cetera, et cetera. And he said, those are real problems. And I just about like, oh. So, I totally respect you for saying that, because you have insisted on radiometric dating being true, but you're honest enough to acknowledge the chemical dates are a problem. And then I began to, there may be this problem of nucleosynthesis and nuclear transformation. When I was at Johns Hopkins, I actually did a term paper, and I thought the professor is he's gonna cut my head off, because it was so radical. But I said, okay, the only way I can get away with this is if I go to the library and search. And I spent 2 days at the Eisenhower Library at Johns Hopkins, and I couldn't believe all the experiments in nuclear transmutation that involved chemical and electrical means. So I was trying to save my grade in solid state physics, and I said, I'll either flunk the course or he'll give me a B, because I'm right now not doing so well. And all the students had to give their term papers in front of we had to do this in front of our peers. And then I said, the chemical and electrical means of changing nuclear structure, and I thought he was going to have my head. After I gave it, he said, that was the topic of the night. Because I cited peer-reviewed literature, and I'm like, this is kind of slipped through the cracks. It's not, it won't make the headlines, but the experiments have been done, and I got very excited. And then finally, the last thing. So I've given you three.
That was great. That was great.
The final last one, and this is a testable prediction. Unfortunately, the ultimate verification will probably, if humanity lives this long, will be after our lifetimes. We have been measuring since like 1860 or so, and even with reconstructions, the decay of the magnetic field. So we have had direct measurements of the magnetic field, and actually there's a difficulty. There's still a we have theories that claim how we understand the magnetic fields of planets and even the sun exist. But they are still theories. One of the problems is when you have n-body problems. It's not so bad when you're modeling like one molecule, okay? You can use all the equations. When you start to have these huge interactions, you're like, this is like a fluid mechanics problem times whatever, times 10. You have so much. It's just like you're making approximations, and you hope you're capturing it, because it's too difficult to model computationally every little particle, of the system, and the only way to model it is to actually have a live model like the Earth, and then you guess. But there's this thing called Cowling's theorem that Russell Humphreys had studied, and it was affirmed by John Gideon Hartnett. John Gideon Hartnett is a young Earth creationist who works for the European Space Agency. He's so
Oh, wow.
talented. They've totally like, okay, we. He makes good products for our spaceships, like the Sapphire controlled clock. Obviously, you have to be pretty sharp to do all the quantum mechanics that he does in electromagnetic. I mean, he's a genius. 200 peer-reviewed papers, which places him really. I mean, that's just insane that anyone could publish that many papers. He's received probably in today's dollars $12 million in grants for all the research that he's done. And he said he affirmed Russell Humphrey's results. And we have been noticing the magnetic field is decaying. NASA's very concerned that it's causing, we have these holes in the magnetic field of Earth that are causing ozone depletion. And it's starting to be very, it may be actually contributing to all the climate variability, or dare I say climate change. And then Russell Humphreys has tracked the decay of magnetic fields in planets in the solar system. And I'm like, yeah, combined with the fact that the rings around the planet seem to be just mysteriously youthful, and also the comets. Now, this isn't definite proof, but it's like, okay, definitely, it seems to be consistent with the decay of magnetic fields. There is one book, when did I become a creationist as far as the solar system? So I was still an old Earth creationist, but I said, I accept the nebular hypothesis.
Okay.
That, there was like a supernova, and then gravity caused the solar system to form. I got the book Solar System Evolution by Stuart Ross Taylor, and in the opening he said, I'm writing this book because I want to fight creationism. Of course, I was curious. I said, okay, this is after I'd studied classical mechanics. I started reading through the book, and he said, we can't solve the problem of how, like, all the solutions either seemed outrageous or they had no solution. And I said, gee, if you're trying to convince me that there's no need for a God, I think you did the opposite. Because I understood the physical problems. I mean, I had enough of classical mechanics to know that what he was saying was like, yeah, I could see why this is a problem, and it's not quite so tidy. I mean, if you just look on, I guess, like on Wikipedia, the origin of the moon, I'm just like, okay, so a Mars-sized impactor hit the Earth, and then suddenly the Earth had, just released this blob. I'm just like, I thought young Earth creationism was crazy. I mean, I read that and I said, do you know how much you have to balance all the angular momentum, and it's still not balanced? All these problems. And I say, at what point would I have to just say, how improbable and fortuitous do things have to be before I think that this is all miraculously created? And when I had, just imagine, I had just finished my third undergraduate program in mathematics with a minor in physics. My undergrads were also in computer science and electrical engineering, minor in music. And I read this book. I'm just like, I think I'm open to the idea of special creation. And if I'm open to the idea that God could just make all this in an instant, I started to become more of a young Earth creationist. So there you go. I vomited it all
That's
out.
great. That was great. It was exactly what I was hoping for and more. Thank you. Thank you. Can I run through those just to make sure that I am properly understanding?
Yes.
Please. So I counted 5: origin of the universe, origin of proteins, origin of life, presumably in that order, chemical clocks and fossils, and decay of the magnetic field. Decay of the magnetic field sort of then relates to a few other things that make things in the solar system seem sort of suspiciously youthful, I think, to try to use your phrase there. Did I get the majority?
Yes.
Of it?
Really good summary there.
I'm taking notes as I go along. It's I'm really smart and I'm really good at tracking things, and I don't have ADHD at all. That's what I meant to say. So let me. Is it okay if I give you my immediate feedback on like how I'm hearing these things and making sense of these
Sure,
things?
I'd love to hear what you have to say.
And some of this is just to repeat the things that you said. So like the origin of the universe, origin of proteins, origin of life, as you said, like these are not specific to the young Earth creationist model. One could be an old Earth creationist. One could be a theistic evolutionist. One could be a number of different. Well, yeah, it could be a number of different things with that. I am. I'm really interested in all of those topics. I'm interested in lots of topics. I'm interested in conceivably too many topics for my own good. I have a couple of businesses to run. I have a world-changing project that I'm working on. I need to focus on things. But in my free time, like I read books about at least the origin of the universe and the origin of life. They're really cool, and I think they're really important things. But they don't touch on the question of whether the Earth is and life is a few thousand years old or a few billion years old, right? There's a factor of 1,000,000 that is between those things, and that's the things that I like to focus on. What came before that, I feel like I'm not smart enough to make them part of my purview.
Well, if I may interject just a little bit.
Please.
Whenever I came to the conclusion of a miraculous origin, it sort of opens up possibilities for. It was important that I took that step and said,
Okay.
I think this is a miracle, and if we can admit one miracle, then, then it stops being so outrageous that all these other things can fall into place. So that was still, even though, like you have accurately said, that these, the origin of life problem comfortably also fits in an old Earth model, it was still probably that was one of the biggest steps, because I would have said, look, if life could have emerged naturally, it's like I wouldn't even had moved on.
Sure.
So that was still an extremely important step for me personally.
Sure.
So
Sure.
we can now talk about
Sure.
whatever you want to. Thank you.
Sure, yeah, absolutely. And I wouldn't, what you're saying makes perfect sense in my own sort of evolutions from one belief system to another, which has happened, a couple different times in a couple different ways. Sometimes I can look back on like some really small, you're talking about really big issues, like some really small issue that I really zoomed in on that none of my friends at the time would make any sense to them. Like, why do you care about this one little thing so much? Well, it's because it's this sort of synecdoche for something much larger. The ones that I am the most interested, the one that I'm most interested in is the fourth one, the chemical clocks in fossils, and then the decay of the magnetic field thing. I want to talk about the decay of the magnetic field thing and ask a couple questions about that, just so I understand what you're saying properly. My understanding is that everyone knows, and you're not saying anything to the contrary of this, but everybody knows that the magnetic fields fluctuate over long periods of time, right? The going model is that every about 100,000 years that they decay, and then they flip, so the North Pole becomes the South Pole.
Okay,
and
so
yeah.
All right, so there is the accepted model that what is sometimes happening in these accepted models is there's a subtle, at least circular reasoning that, first we are assuming an old Earth, and then we are looking in the magnetic field and then extrapolating all these dates. What we do have in hand are actual physical, the only time we've actually physically measured it rather than interpolating it by looking at fossils like the magnetite there's some people that's all they do is study, the magnetic orientations in rocks or whatever. I don't know.
Igneous rocks under
but when we actually look at, when we're doing physical, this is where I was saying it would probably be after our lifetime that we would actually have verification. I mean, if the magnetic fields across the entire solar system decay in 10,000 years, and I need to point this out, Wikipedia is constantly being re-edited.
Mm-hmm.
I had one edit where it said the magnetic field is expected to decay in about 10,000 years.
Okay.
And I found that really funny. And they've since changed that, but I'm like, okay, but if you look at an exponential decay curve, okay, so exponential means you fade away, but you never actually die.
Yeah.
In the electrical engineering convention, after five time cycles, you consider it virtually dead. And so we have this, in an exponential decay curve, you have like the decay constant, and you can calculate, okay, let's say it's every 2,000 years it's going to decrease by, I think the number is like 63%. After 5 of these cycles, it's going to be virtually zero.
Sure.
And we would just treat it, as zero, practically speaking. So it's not that it would actually, I don't know that it totally decays, but if we, and I was talking to Russell Humphreys, I said, okay, so, how soon do you think it's going to get that effective zero? And I don't have it off the top of my head, but 10,000 years seems reasonable. But even in my own lifetime, I looked at the decay. And I'm like, this is a few percent. That's a lot, in my opinion, where we've actually physically measured it. And I'm like, okay, if we were going to be, as I were teaching this to my students, I say, look, we only have this small sample size, and there's always a problem with sample sizes. But in the whole time that we've actually measured this, it is decaying. The other problem that we haven't solved, that no one has solved, what causes it? It cannot be like a permanent magnet. A permanent magnet is not under the intense heat. And I learned this in electromagnetic theory. You could either heat out the magnetism in a iron magnet, or even hammer it out.
Mm-hmm.
So what is creating that magnetic field? The current prevailing theory is the dynamo theory. And Russell Humphreys said, Cowling, who's a famous physicist, he said there's some problems with that. And this is actually a little bit way outside of my specialty, but the fact that John Gideon Hartnett, that European Space Agency young Earth creationist, was endorsing this work, I said, he's a pretty smart guy. I have to take that seriously, especially since he's again a top tier young Earth creationist. He's so good that the secular world will accept him to help them build spaceships. So okay, I would just say, how about we leave that as an open question? And I'm actually relearning electromagnetic theory, starting with Maxwell's equations, and I was like, yeah, even for me just to understand some of the issues is going to take me a while to learn. But
who's the physicist who said, when I die and I get to talk to God, I will have 2 questions for him. Why? Oh crap! I'm going to get this wrong. Like why? The weirdness with the collapse of the waveform, and why fluid dynamics. And I'm pretty sure he'll have an answer to the first one. Okay, here, can I repeat back what I'm hearing you say here?
Yes.
That if the question is, what's wrong with the mainstream model of magnetic fields flipping, right, that does that over long periods of time? One of them is that we don't even know, we're not even confident.
Oh, no, it's not the flipping, it's the generation. We can generate magnetic fields through a variety of methods, kind of in our man-made world.
Uh-huh.
We can also make permanent magnets. How we get geomagnetism, because we can't really open up the Earth and examine all the parts inside, we have to make inferences. And so Cowling's theorem has been claimed by young Earth creationists like Russell Humphreys, but then endorsed by John Gideon Hartnett, who is a respected secular physicist on top of being a young Earth creationist. He seems to endorse the interpretation that Cowling's theorem is making it difficult for us to assume that magnetic field could have been here for a long time. Now, I don't know all the mechanics of this. This is where I actually got excited and said, I want to study science more so I could understand the details of this discussion. So you're asking me about the most difficult part of the young Earth model that deals with some of the most difficult physics that I'm actually not very good at.
Sure. Let me try this again then. So I'm hearing you say that one of the things that pushes you in the direction of young Earth creationism, of that model, is that we see the magnetic field decaying as much as we do. Is that part right?
Yes, both in Earth and with what little we know,
Uh-huh.
and all the planets of the solar system as well
And
that we have measurements for. Okay.
okay. And an alternative to that could be like that we could have seen that on Uranus and what else has a magnetic field at this point? Jupiter, I think, right? Both of those have magnetic fields. That it's going the other direction. It's waxing, not waning. Is that right?
I
We
don't
happen to.
know. So,
Okay.
so this is, I mean, in the strictest sense, even though it'll be outside of our lifetime, this is a testable prediction
Yeah.
that if it's decaying and it's a reasonably steady rate with some fluctuation, it'll approach zero. We haven't figured out what the time constants are for each.
I guess what I'm not following, though, but maybe I do, is that it seems like the mainstream model of the universe has a ready explanation of this, which is that the magnetic fields ebb and flow, and in fact we see evidence for this in the magnetic stripes that make up the bottom of the Atlantic Ocean.
Well, it's not. We're looking at kind of like our observations. I'm looking at mechanisms. So, mechanisms in terms of like, okay, how would you have to move matter, or what would you have to do to matter to make it generate a magnetic field? So when we're building motors or generators, sometimes you want to develop a magnetic field so that the coils can pass through that magnetic field and generate electricity. So we have some idea how to make magnetic fields, but how we would make it on a planetary scale, where the internal part of the Earth is molten. You know, we don't build magnets that are made of molten iron, for example.
Huh.
And so how mechanically is the magnetic field generated? And even the young Earth creationists are like, okay, we think there could be motion. When you have motion of charged particles, you generate magnetic fields, but then there will be friction because when you have moving objects, there's going to be friction and that's slowing it down. And we just don't, we're fighting. There is an internal fight in the young Earth community as to what actually develops the magnetic field. So I don't know that we've done a lot of experiments with molten metal to figure out, gee, how can we generate a magnetic field and we just have molten metal? Because, like I said, if you melted a permanent magnet, you're going to lose its permanent magnetism. So now you have to find an alternate mechanism to create a magnetic field. So some of the theories are dynamo, and then,
And dynamo here basically means a bunch of molten metal flowing in currents in the outer core of the planet.
I don't know enough.
Okay.
I don't know enough.
Okay.
I do know enough to say I smell like something where what is represented to the popular press and even to some extent to the researchers themselves has not been rigorously established by any experiment. Part of the problem of establishing it by experiment is it has to be on such large scale that you might be able to, you'd be able to generate detectable magnetic fields. So there's still a lot of speculation. And as you said about fluid dynamics, this could be a fluid dynamics problem. The only thing we know by direct empirical observations is the measurements that we've made around since like 1860. Direct measurements with instruments, not looking at stuff like in the fossil record where we implied that it flipped. Even the young Earth creationists believe the magnetic fields have flipped, but they feel that it happened in a much shorter time frame. But so this is an area I'm just going to say, look, I'm going to grant I would say the young Earth creationists have open questions on this. I think the mainstream needs to be more open about, the validity of their claims of the mechanism, because they want to have a mechanism that perpetuates the magnetic field for, hundreds of millions of years. And it's like, well, how do we know that it can actually do that theoretically based from first principles of what we know about molecules and Maxwell's equations, etc.? And I think this is this is fruitful. This is a fruitful area for exploration,
Hmm.
and this is one where I said I'll be a gambling man here, and uh,
So let me state where I agree with you and where I think that trying to figure out where we're disagreeing on this. I want to first say thank you for calling my attention to this because this is actually something that my son and I have been kicking around. He's 15 years old. He's really engineering minded. We've been kicking around like, what do we think is actually going on, and at the core of the Earth that is causing these sorts of fields, the poles and what have you. Why do these things flip? And frankly, I've just assumed that this is the sort of thing that I could ask ChatGPT to answer and would very cogently answer it very quickly. And I've been holding back on that because I've been enjoying living in the mystery of this. And so to find out that actually, maybe to some extent, this is an unsolved problem makes me feel smart and cool. And also, more importantly and usefully, makes me feel more alive to this entire thing, right? This is one of the things that I really appreciate about dialoguing with people who believe very different things than I do, because my attention will be called to some part of the world that I never really looked into before, and all of a sudden, like that takes on new meaning, right? Because it can be used as this synecdoche, as this little pivot point, that if it goes one way or the other, it could prove one whole very different model significantly more likely than it was before. Like this is great. This is intellectual thrill seeking 101. Thank you.
oh, you're welcome. And if for nothing else, sincerely, science can be so boring, and sometimes it brings actually a lot of excitement is the unanswered questions.
Yeah.
So finally, I've got motivated to start pulling out my electromagnetic theory book and relearning electromagnetic theory. Now I have a passion to study these subjects that had seemed so boring and really laborious and actually agonizing. Electromagnetic theory was a tough course. The worst course I ever went through was classical mechanics, Goldstein's mechanics. You'd think classical mechanics should be easier than relativity. The way they taught it at Hopkins was just brutal. I'm still traumatized after over a decade. I'm like, that had to be the most suffering I've ever been through. Anyway, so when you're talking about being invigorated just because you have an unanswered question. See, I mean, do we ever watch drama? I mean, there's a reason we watch football games or anything that has uncertainty. The drama is inspiring. It's thrilling. And so it has sparked my curiosity to start learning. And so just actually yesterday I was going through, okay, let's see if I can memorize Maxwell's equations. The first equation is the divergence theorem. See, del dot E equals rho over epsilon naught. The curl of B equals 0. So I at least memorized 2 of Maxwell's equations. I'm working on the next 2, and that'll be all 4. So, and it's like that's just the basics, just to be able to even begin to understand the discussion. And I'm like, okay, this is at least now I'll know. I'll have a little bit more knowledge. By the way, I have an interview that I posted on my academic channel with Russell Humphreys, who talks about Cowling's theorem and the Earth's magnetic field. I had 2 episodes recorded. I'll just send that to you in case you want to have yourself bored to death. But it was exciting when I began to think more on these things. So I'm sorry I haven't been able to give you really good information on the magnetic field issue. I am kind of, I'm such a newcomer to this, but I'm at the stage I want to learn more and more.
I am now having my computer is melting down and it's saying that it's not recording me anymore. Why, computer? Why? You spend thousands of dollars on a computer to do one thing and then you ask it to do it and then it doesn't do it anymore. How is
I'm
my
getting
studio
an
system?
upload. It's saying uploading 100%. So
That's you are blessed among men. I was about to say women, quoting the angel in the book of Luke. What went wrong? Hold on, I apologize. And for everyone who's watching this, this is embarrassing on my part. New recording track created a new recording track started due to changes in your device. Great. We'll just try. We'll just try this. Okay, I can now. It's offered me the opportunity to chat with supports. Okay. Um, I'll just go as if everything is going great right now, and then we should wrap up because actually, my wife is expecting me home. We are babysitting some of our friends' kids, so they can go out on a nice long date with one another. Parents gotta stick together for this sort of thing. Um, I was trying to bring up on my computer, which maybe was the thing that caused the audio part, the recording problem. One of my favorite science books, which I feel like does this better than almost anything else. It's called "We Have No Idea." Here, I can share this. My computer is really melting down. Well, how about that? We Have No Idea, A Guide to the Unknown Universe by Jorge Cham and Daniel Whiteson, the UCLA physicist. And the book is organized around the questions that we don't have the answers to. Why does the universe have a speed limit? Why aren't we all made of antimatter? What is dark matter, and why does it keep ignoring us? Things of that nature. And it's just wonderful. And because it's organized around these things that we don't know, it makes it all the better. Okay, so can I respond then to what you had just said with this?
Oh, please.
I hear you saying that we don't know what the mechanism is by which the magnetic fields are created, and that mainstream science and young Earth creationist science, neither of them have a clear answer to this. And I hear you from that, now maybe I'm getting you wrong here, concluding from that this should cause us to update and think that young Earth creationism is more likely than we would have thought before. Am I hearing you correctly?
Yes, one slight modification.
Thank you.
It's not that we aren't clear, it's that we haven't had. There is no one theory that is the unequivocal winner at this point.
Okay.
And I'm sorry, I'm getting a spam call. I should have shut off my phone. Get lost, you rodent. I'm speaking to my spammer here, not you, brother. So let me try to shut this thing off. This is so annoying. They'll try to bombard me again.
No, I appreciate that we're going back and forth in our irritating tech
yes.
issues.
So you're really close. I would just say it's not, uncontested or unequivocal.
Sure,
one model that is universally accepted. And yes, I wouldn't, as I said, it's not a proof of young Earth creationism, but I began to be heartened because when you have nothing, even a morsel can kind of inspire, reassure some belief. But the main thing was chemical dates, if you ever want to cover that, because I'm more knowledgeable about that.
Sure. Can I before we leave this though,
Sure.
say one more thing with this? To me, the fact that we don't have a mechanism, we don't understand the mechanism, in no way surprises me. We live at a certain moment in history. 100 years ago, 200 years ago, nothing was figured out, basically, in an actual fundamental physics. We didn't have Maxwell, we didn't have anything, we didn't have Faraday. And now, we shouldn't assume that we should have everything now. And so that doesn't give me any pause at all that the mainstream theory is wrong. What's important for me is that we have this evidence that it is a normal thing for the fields to switch. And presumably, maybe there's evidence for this, before they switch, they diminish. So in my mind, the mainstream model has no trouble making sense of as to why it's diminishing now at all, even though we don't have a mechanism yet for it. What's your response to that?
I would say, I'm not that familiar with the mainstream model, and except that it predicts that we've had a magnetic field that hasn't decayed as fast even if it has been decaying, how fast has it been? And so, um, I just, what focused my attention was the actual physical measurements, not stuff that we took a fossil and said, we're seeing the flips. Even young Earth creationists they've
Yeah.
said we agree with the mainstream that the poles have flipped.
Okay. Yeah.
We disagree in the time frame, and so I mean you're really by the way you're really very accurate generally in the way you describe things. Most of the things that I might interject are just kind of like, okay, maybe I wasn't clear. This is what I meant, and
Thanks.
I do want to say, you talked about you alluded to the 19th century, like 200 years ago.
Uh-huh.
We really didn't know anything. We didn't even have atomic theory. It was, in fact, it was in the late 19th century. There was still a debate whether atoms existed or not.
Yeah. Yeah.
And so the problem we have now is it's like, okay, you would think since we're able to model the atom and the periodic table, etc., we'd be able to figure out where the magnetic fields come from. The problem is when you have an n-body problem, when you have multiple particles, that is like, again, the fluid mechanics problem.
Yeah.
It becomes nightmarish. In fact, it is so difficult that you might as well just try to make a physical model than try to solve it computationally. That's why sometimes we had computational fluid dynamics, but we still had wind tunnels because the wind tunnel would actually give you the best data possible for the longest time, better than computers. Now we're starting to flip on a few parts, but I think the problem of modeling that many molecules and, different whatever is going on in the center of the Earth. And I need to add one thing. I think the deepest we've drilled has not been much more than 10 miles down.
That's correct. Yeah. It's about 13 kilometers.
Okay, so we're going to make all these inferences about what's going on in thousands of miles beneath as far as we've actually drilled. We don't know so that's another problem. We actually don't know physically. We can make a pretty good guess what's down there.
We have ways of using P waves and S waves and from earthquakes and whatever.
Right,
but you're right. This is all educated guesswork. Absolutely correct. Yeah.
And so what we really, we might say, okay, this is thicker here. We have to guess about the composition of the chemicals and the kind of atoms and molecules and also variety of things. And it's like, okay, and there's still disputes in the geological community about things like mantle plumes. It's the structure of all this stuff going up, and it's like, look, there are too many uncertainties, and so I'm not trying to say that the scientists on either side are dishonest. We really don't have. It's not like we can do stuff in a test tube. This is why I like biology. We can actually examine stuff in a test tube, throw a bazillion instruments on it, but the stuff that's going on in the center of the planet is. That's one reason and even worse is astrophysics. You're trying to describe the structure of the internals of a star that's a bazillion miles away, and all you have is this little dot, and you're applying spectroscopic stuff. I'm just like, look, I think I'd rather do a different field of physics.
See, this is interesting because I feel like this is maybe to go then to exactly where you suggested, which is the chemical clocks in fossils. I think I have a similar objection. Objection is way too strong. A similar reaction to that as you do to stellar mechanics, to astrophysics. The old joke about the drunk who's looking for his car keys and he can't find them, but it's because he's only looking under the lamplight because he couldn't see anything else there. So if it's not under the lamplight, so why bother? I think I just ruined that joke. But I feel like what I've seen some young Earth creationists do is almost the inverse of that, where aspects of science that we have a lot of really great evidence that all coheres really well with each other, that has been, settled science for hundreds of years. They diminish that stuff and will go and look at really complicated stuff that requires computers and abstractions to even begin to wrap our minds around and say, well, something that's going on, something that we see and hear, should make us update really strongly on, our overall model of the universe, which it totally could, right? It absolutely could. And I stand by the thing I said earlier, where some small discovery somewhere, the fun of it is that it could upend everything. But then to upend everything, like in apparently the end of 12 Angry Men, like there needs to be a way to go back through all of the other evidence that one has collected and say, okay, how could we have been so wrong about these things that seemed so clear? And in a really well-written drama, my daughter is actually reading 12 Angry Men right now. Shout out to Luke Travers if he's watching this in his wonderful online literature class. Even if literature at ourhouse.com, if anybody's interested. Sorry, he's an amazing teacher, and I love that I get to talk to him sometimes. In really well-written literature, you can do that because you wrote, the initial evidence with an understanding of how, you were going to undo all of that. But in the evolution, young Earth creation debate, I feel like we have all of this really solid stuff of like that would need to be overturned. And it seems weird that we're looking at something as hard to understand as chemical clocks, which you understand much better than I do, and I will would love you to educate me on. And overturning the stuff that we can see with our own eyes. Thank you for letting me spiel about that. Mm-hmm. What is your reaction to that?
Well, what has heartened me was when there's been dissent, it wasn't the young. This is something that I've encouraged young Earth creationists not to do. I actually encourage them not to cite other creationists. And a lot of my work has been looking at the secular world and trying to be sensitive to like the ignored expert who said something that everyone ignored, but he's a top expert in the field. So, for example, Nobel Prize winner Roger Penrose, for the longest time, I was saying, gee, when I was sitting in my astrophysics course, my cosmology course, and I thought this inflation field where stuff is moving faster than the speed of light. Actually, it's technically not. It's like, well, space is being inserted in between the objects, and like, whatever.
Yeah. Well, and then, okay. There's as you pointed out, there's an important difference there. Yeah.
Okay, but then Roger Penrose, I only found this out after he won the Nobel Prize. He may have said it even before he won it, but he won it for all of his work. He's a brilliant guy. He said the inflation field's nonsense. And I was like, gee, it was being taught to me only like 12 years ago as hard fact. You've got one of the top scientists in the world saying what I was learning in my textbook was nonsense.
Okay.
And then also I was at George Mason University. 3 of the professors, one of them, Minas Kafatos, who got his PhD at MIT, he was a distinguished professor of astronomy, and he said he didn't believe in the Big Bang, and then 2 of his colleagues. So it's really funny, I'm taking these elementary physics courses in, when was it, like 1989, and I didn't know there were professors who were like, I don't believe this. And of course, as a student, you're like, this is really curious. You have professors here that disagree with the textbook that I'm being graded on, and I'm like, this is kind of fun. And then when I was at Johns Hopkins, when Adam Rees won the Nobel Prize for the supposed discovery of dark energy, there was one of my professors, who shall not be named, said, I'm not really sure that that's right. Mm-hmm. And then I had another professor said, hey, just between you and me, I don't believe in dark matter. And just like, okay, all right, so all this textbook physics, and of course, even if I weren't a young Earth creationist, you're like, anything that's kind of forbidden knowledge that you're not supposed to say, you just start to eat it up. Mm-hmm. And I should also mention at George Mason, okay, I'm sorry, I'm just giving you a cultural anecdote here. Right when they were dissing on creationists, I had to point out the irony. I said, did you know that you have awarded 3 PhDs in biology to 3 young Earth creationists? Timothy Standish, Gordon Wilson, and Timothy Brophy. And then that's in addition to Carolyn Crocker, who got expelled. She was a professor of biology for her ID sympathies. And then there is a kind of wacky young Earth creationist who got his PhD, that he was a biology student at George Mason also. That's Charles Jackson. And then, of course, yours truly. So I'm just like, okay, this is just kind of a fun time to be alive, where you have all these forbidden ideas.
Yeah.
And even secular professors are quietly saying, what you read in your textbook isn't, I don't agree with that. And of course, your curiosity, your eyes start to pop out. It's like, I want to hear more. Why don't you tell me why you disagree with what's in my textbook? I mean, so I just wanted to say it's not, you may get what you described about other young Earth creationists, I would have to agree. They may be just stretching things, but I'm just saying, as someone who's had his boots on the ground, hearing it from secular teachers, even if I weren't a young Earth creationist, I'd say this is, kind of like things you're not supposed to say that might rock the boat. That kind of makes it even more interesting.
I feel like this is something that I didn't know about before you and I started talking. That the Academy, the biological sciences, had as many young Earth creationists in it as you say, and I can totally imagine that, because I have a master's degree in educational leadership, and it was just a factory for pumping out an accepted narrative, and there was no real there's very little real intellectual inquiry, and right, like the ideas were stamped down on pretty hard and attempted to be stamped into people pretty hard. Like I know the failings of the Academy is what I'm trying to say, and so it doesn't surprise me that there actually be many more heterodox people than you would guess if you asked, than you'd find if you asked for a show of hands in any faculty lounge. I'm so familiar with the pull toward forbidden ideas, and I feel like I've had to correct in my life to not be overly pulled to forbidden ideas, because sometimes the mainstream is actually right about things, and I've had to correct myself in the last few years. Not going to give any examples, probably too contentious, but I've had to correct myself on some of these things. And of course, sometimes the forbidden ideas turn out to be absolutely true, and then eventually the whole edifice comes around to agreeing with them. So all of these things are possible. I believe this. What I'm not hearing in this, though, in what you had said, is an answer to, a response to what I said about it feels like people are looking, that young Earth creationists, even the top tier ones, that you so wonderfully represent, and thank you, Sal, for meeting with me. It feels like you guys are looking outside of the circle of light from the lamp for things. And you're that, I shouldn't say you here, and that the community is either not addressing the things that are the most well known, that seem to be disproving of the young Earth creationist model, or I've heard you and sorry,
we blanked out for about 5 seconds.
Oh, I'm sorry about that.
So the young Earth community is not addressing the things that are most well accepted, or you said well known.
Yeah. Let me actually say this better, because I think I'm not happy with the way that I was saying that a second ago. The low tier young Earth creationist community ignores or denies the more well established data that doesn't fit with it. What I see the top tier young Earth creationists doing is acknowledging the well-established evidence that is a problem for their theory. And in fact, like in the case of Todd Charles Wood, I think I'm getting his name right still, like positively exulting in it, and I think that's wonderful to do, and saying this is a real challenge for us, and we need to go on this quest to answer these things. But then when I look into what the community is doing about this, what I find is a lot of like really bitter infighting about, for example, as you were pointing out, like where do we find the flood in the geologic column? This. Do you want to react to that? Do you feel like I'm actually giving a?
Yes, yes.
Yeah.
So you will hear like Todd Charles Wood saying this is well established. He thinks evolutionary theories on very good footing empirically.
Yeah.
As a student of physics and chemistry, even though Todd Wood technically got his PhD in biochemistry, I thoroughly disagree with him. I think
Sure.
evolutionary theory, even by the admission of, evolutionary biologists themselves that have jumped ship, is problematic compared to other scientific disciplines, and I've totally seen that. And some of my peer-reviewed work has been showing it's like, look, some of the holes had been identified by evolutionary biologists. One of them, namely, the definition of fitness, and that's when I spoke at the big evolution conference of the world in 2025. By the way, my shameless self-promotion, my talk was the most viewed.
Sal, can I just say that one of the things that I love about you the most is your delight in self-aggrandizement. And I don't mean that in a negative way. I come from the Midwest. People here are pathologically afraid of doing anything that could be mistaken as that. And I find it so charming. It was one of the reasons that when we first engaged on that subreddit, I was so excited to talk with you. Anyway, do continue.
I mean, sometimes it's like, well, yeah, I self-aggrandize, but it's like, well, I think I'm better than most young Earth creationists, honestly. I feel that I've studied some of the areas, and I'm more versant in it, and I think I'm able to argue my points more effectively, because I sometimes cringe at what they say, and it's like, stop saying that. This is the way to say it. So I feel very passionate. It's like, look, you can say things better. And part of it is just knowing the literature. You'll have honest admissions from evolutionary biologists. One of the ones, Richard Lewontin, he wrote a book. He wrote an entire paper. He was one of the top evolutionary population geneticists.
Mm-hmm. He worked with Stephen Jay
Probably
Gould a lot.
just below Sewell Wright and Ronald Fisher and J.B.S. Haldane. You get that other tier, that would be Richard Lewontin. He said it's not entirely clear what fitness is.
Mm-hmm.
So if Darwin's theory is survival of the fittest, and you can't define fitness in any way that resembles other physical theories, like in physics, where you at least have some way of measuring, like mass and length and charge, you don't have a way of doing that objectively in terms of fitness. And I'm like, I totally saw that. I see it in the math. I published on that. I presented it at an evolutionary conference. There was an uproar of it. I'm like, what did I say that your guys haven't said already? And you know it's a problem. And I said, that's very problematic. You're not going to have a scientific theory if your fundamental quantity, like say Darwinism, cannot be defined and it cannot be measured. I said, this falls apart. And so when Todd Wood said, this is a really good theory, I'm just like, you got to be kidding. You got to be kidding, because your main guys like Andreas Wagner and Richard Lewontin have pointed this out, and then I can also show it, not that my word counts that much, but I mean, I would know how to show this proof as well, especially since I've studied some biophysics. I said, you're using totally useless metrics. The way you should measure, and that was my whole point when I presented at the evolution conference, the most objective metrics are the ones the biophysicists are putting out, not this not your conception of fitness that is just a measure of reproductive efficiency in only one environment, and you're going to come up with just these terrible conclusions. Like there was an experiment by Richard Lenski. He said, well, the genome's decaying despite the fact there's sustained fitness gains. So I'm like, let me get this right. The survival of the fittest is happening. They're getting more fit, but they're losing genes. I said, don't you see that there's a disconnect here? And by the way, this is ubiquitous. There's a tremendous loss of genes when you're actually increasing fitness. This is the dominant mode of evolution. I didn't say that. That was Eugene Koonin, who's the top evolutionary biologist on the planet. And I keep getting ignored, and it's like, okay, they'll say you quote mine. I'm like, okay, you could say that, but why don't you read your own literature? Because I'm going to have a field day with you guys. I did not quote mine him. This is known. This is experimentally and observationally established. Even without antibiotic resistance, there are issues with that. So I'm sorry to get on my... I'm getting a little passionate about this. And I was like, well, look, I have certainly dealt, at least I can speak for myself, I've dealt with what has been universally accepted. And I've shown, not because of me, I've shown your own guys pointing out their concerns, if not utter refutation of what you've been saying is solid. So what you say, what is presented to the popularized science people, and even to some extent your textbooks, the top tier of evolutionary biology is on my side of this issue, saying, there's a lot of work to be done to actually make this a solid discipline. So I'm sorry. Now you got me on my soapbox.
Can I react to that?
Oh, please.
But then I also need to say that I need to go too. Do you want that to be the last word? Actually, I'm happy to. I don't want to give myself.
I'd be happy to continue this conversation, and I would be happy for that to be the last word, and that'll be the cliffhanger to get your reaction.
It's my turn to do that. Okay, absolutely. Everybody, thank you so much for watching all the way to this end of this very long conversation with two guys talking stuff. It's been a delight to do this. Sal, thank you so very much.
Thank you for giving me the chance.
Yeah. All right. Toodles, folks.